Okay, the problem is Jam Game 7. So maybe they will cover all the Jam Game problems within this May only. Don't know. Okay, let's see what is given. We're given a binary zero index binary string. So that means one string, it's a string is given. So and two integers, minimum jump and maximum jump is given. So I have to I'm standing an index zero. That means I have to start from index zero, and which is also equals to index zero. So in the constant you can see index the first character of the string is zero. It is given. So I can move to index I to index j if and only if uh, it is this j index should stay between main jump and the max jump or length of the length size. Okay, size of the string length. So if it is given, let's say 0, 1, 1, 0, 1, 0, this kind of thing. Let's say if my min jump is 3, min jump is 3 and max jump is 4. In that case, starting from here, min jump is 3 means from 0, 1, 2, 3, 4, 5. So in which range? Like 3 jump is 1, 2, 3 and 4 jump is 1, 2, 3, 4. So within this range I can jump. Okay. So j should be in this range. And another case and j should be also 0. I can jump 0 to 0, not any other index. So to return true if we can reach length of s, length of last index is dot length minus 1, or otherwise we will return false. If I reach here, then I can return true, otherwise I will return false. Let's say this example. So from this index, can I jump min jump 3, max jump 4, minimum jump should be 3. So 1, 2, 3, I can jump here. From here, can I reach the last index? So 1, 2, I need 2 jump, but minimum jump is 3. So I have to take at least 3 jump. So I cannot reach in this index. Okay, so that's why it is false. So let's say maximum jump instead of 4, it is 5. Instead of 5. So what will be the case? Here I can 3 jump, I can reach here, but I cannot go here. Correct? From this index, I cannot go in this position. Okay, but here I cannot. Can I go there? 1, 2, 3, 4, and 5. I can directly reach to the fifth index. So I can directly jump here to here. It is a valid case. Okay, let's see the constants. Constants are length could be 10 to the power 5. So my approach should be big of log n or something like that. And should be is I know it's a binary string, so it will be 0 or 1. Starting it is big of 0. First index, first item is 0, and min jump, maximum jump. Min jump can be less or equals to maximum, and it is both of them are should be the less than my length of the string. Fine then. So let's see some example test cases. This is the cases. So this is the case. So here I can see where from here can I min jump is to maximum is 3. Can I reach? Let's see some diagram. So can I reach in this here? So here I can 2 jump means 1, 2. I cannot reach here, but 3 jump, right? So 2 starting from here to here I can jump in this range. So here I can jump here, and again I can 2 jump, I can reach here. So it is a valid case. Can I reach here with the 4s and 6 jump? So can I go there? Let's say 4 jump. So 1, so it's to start from 4 jump right here. 1, 2, 3, 4. The range starts from here to 4, 5, and 6. This is 2. Okay. So here to here I can jump. Then I can jump here 4. Then if you see, like if I jump here in this place, if I jump in this place, then I cannot jump here because here to here I need 3 jump only. So that I cannot, but if I come this place, I cannot go here. So from here, I could directly jump here because my maximum jump is 6. It is taking only 5 jump. Like 1, 2, 3, 4, and 5 jump. So I can reach here. Okay. So can I start from here and end here? So see, last index is 1, and it is given like I can take I can do a valid jump if and only if my current value is 0, index value is 0, and if my last index is 1, so no way I can reach the last index. So that's why I cannot jump in this place. Okay, can I come here? So here it is 3, it is saying 3 minimum and maximum is 4. So 3 here I can jump, also I can jump here as well. So here can I jump any other place? Can I jump 4 means here I cannot jump, but here I can jump here, therefore I can jump here. So after that I come here, but can I jump in this place? No, right? I cannot jump in this place. So this is also invalid case. So how could we approach this problem? So this seems like a BFS problem. So I have to take the reachability from one index to another index. I need a reachability. But in this case, there is a one problem. In this case, the problem is I need to find the adjacent nodes. I have to need to find the adjacent points. So for finding the adjacent point, I have to iterate a loop. And minimum, maximum could be anything. Maybe I have to iterate for each and every cases. Okay, and I can jump here, I can jump here, then I can reach here, I can reach here, I can reach here. These are the reachability. So now I have to check what is the position from min jump to max jump range. What are the case where can I reach? BFS, BFS I can use. So I have to check the reachability from here. Where what are the places I can jump? What are the places I can jump? And I can go there, mark them as visited, and jump again. This is how we should do until or unless I reach the maximum place. I reach the maximum place. Okay. So you can think of BFS here, but BFS has some problem. BFS has some problem. So assume it will give a time limit exit error for some time. So if this is the case, everything is 0, 0, 0, 0, 0, 0, 0. Let's say some 10,000s of zeros are there, or and some what is the actually 10 to the 5 is right. So 10 to the power 5 is there, right? So let's say fast 10 to the power 3 is there, and another 10 to the power is 0, then something is 1 is there, and something is there. At the end, again 0 is there. Okay. So if that is the case, and let's say minimum jump is 4, 1, and maximum jump is literally kind of many items. So assume like only from this one that is reachable. Assume for this one that last item is reachable. Okay. So what actually do? You have to jump here to check each and every case. Minimum jump is 1, so I can jump here, and maximum land just a 10. So from here I could check like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up to this I can jump. From here up to this I can jump. Here I have to check for every cases. Like for BFS I could start from here, and from this range I have to check like in this range of that I have to check. Can it be my next case? Can I reach there? So reachability is a see, we don't have the adjacent nodes. BFS will only work when we have the what is the fixed thing. Like from this node, I can go up to this node. If there is some, if I have the path, adjacency path, like if this is the path, adjacency matrix is present, then BFS is helpful. But finding out the adjacency matrix takes big of n squared time, if you know the graph. So here from starting from here, I could check, let's say minimum jump is 1, maximum jump is this range. So every time in this, let's say 7, 1, 2, 3, 4, 5, 6, 7. Within this range, for this case, I have to find like how many zeros are there. Then I have to come here. If it is 0, then fine, or not 0, then you have to go past. And then here I have to say what is the 0 or 7 in this range. So each item I have to visit and check. This is how we have to do. So each cases you have to mostly we have to consider each and every item. So here I am taking, let's say, this item. After this index I am visiting. For this I am visiting this index. For this I am visiting this index. So it is mostly for one index case. So I am visiting all other cases. Say all are 0. Let's say all are 0, and jump is 1 to 10 or 9. So I have to visit, come here and check whether this is visitable or not, is it visitable or not, is it not. I have to check. This is the thing I have to check. So this will take too much of time. This will take too much of time. Okay. So VFS will help you. VFS will not help you. Okay. So let me give, if you don't actually satisfy, let me give you a proper example. This is the case. You can see I applied BFS here, but it is giving time limit exit. You know what it is there? You can say minimum is 1 and maximum is 50,000. You can see only 0 here, but I note if you expand the test case, test case 120, if you expand the test case, at the end, my like all are 1, as it is showing as all as 0. In the end, everything is showing as only 1. And last case was 0. So you know what is happening here. So this this case is only reachable by this one. But to reach here, I have to check each and every cases. Okay. So let's say everything is 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Last thing it is 0. So this is only reachable, this 0 may be reachable from this 0 or this 0 or this 0. Anyhow, this from here, I have to do some steps and I have to reach in this 0. Next, then I have to this from this 0. This is 50,000. That means from here I have to check for 50,000 case. Maybe I'll reach. As soon as there are some, I will reach here. From this 0, I'm checking from here and I have to iterate for 50,000 again, right? From here. Then this 0 again 50,000 this here. This is how we have to do. Like BFS should work. Like minimum then in this range of minimum then or maximum then I have to iterate in case. Like I have to check whether can I reach that place or not. So it will take n square of time because in every time we are checking for each index I'm checking in the range like what are the my next possible uh, index is possible, so that's why I'm checking or I want to find it out. Okay, so there's the reason that BFS will not help here. BFS will not help here. So what are the other things we could do? So could we use any other approach to do this? So I thinking different way. I was thinking start with the BFS only, normal cases. Then I noticed like it is not a case. This is not. It will help. So I thought a different approach. I use only same approach like what we are doing, like Q approach. So this approach came from yesterday's problem actually. Yesterday's or day before yesterday's problem. Jam game file. Whenever I was a monotonic stack kind of approach I was using. What I am actually using here, not monotonic stack you can say. I will see here when I got a zero, I inside that thing into my queue. Okay. Let's start and not take not simple example, not take this example. This is a good example. Copy. And I will take this example. Not only take this example and remove others. Okay. So if I give some indexing here, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 index. Okay. So what will happen? I'll start from 0th index. So I have to start from 0th index, right? So inside my queue, I inside 0. 0 is the index here. 0 is the index here. Please remind it. Then I'll do what? Then from where I can jump, I can start searching directly. Okay, where can I start searching directly? From 0, I have to take the minimum jump. Minimum jump is 4 and maximum is 6. So if there is anything present between before the 4, like 0 to 4, I can jump. Minimum jump start. So I shouldn't look from this, I shouldn't look into this case. What is present here, I shouldn't take into this case. So my minimum jump should start from the minimum jump index. From which index I can start? From this one. From this index, I will literally iterate each and every case. Normal iteration. I have to check whether it is 0 or not, whether it is 0 or not, whether it is 0 or not. I have to take that. So, okay. So, I will do what? For, and this is my queue. In the queue, I add what? This is a queue data structure. Queue data structure, what I added? I added queue dot add. Add what? 0. 0 is nothing but it's an index, not a value 0, it's an index. Let's write a function as well. Let function and what I need, what is the name? Can reach what is given. One array is given. Let's say ARR is given. Mean jump is given. Let's say mean j, and maximum jump max j is given. Max j is given. Okay. So I'm adding into the queue and add this thing in the queue. Okay, 0 is there. Now I will start from where? As I told you, I start from the minimum jump. So for my I, starting from my min jump, up to which I have to do, I need also my n, length of the n is nothing but arrow dot length as usual. So I equals to min j, I less than my length and I plus plus I'll doing. So assume I got one I index 1. If it is my index 1, so if I got one here or one here, should I do anything? No, because I should think of my 0. I shouldn't think of my 1. So I will simply update That's why I'm writing if my s. Okay, it is not array actually. Why I'm writing array? It's an actual string. It's a string. It is s. So it is a string inst dot length. Okay. So if my string of I is actually 1, my character present in that index is 1, then I can do what? I know I will not do anything. I will simply continue the loop. I will not check anything because I need 0 only content. Else, what will do? So if I got any 0, I will check whether from which place I can reach here. Can I reach from this 0? How could we check? How could we check? Can I reach from, like, what could my previous case? Previous case. So this should present if it shouldn't, like, what is this 0? This fast item in this queue is representing the fast item. But I am getting the 0 in the order. This is the index position of the fast 0 I am getting. So this 0 is present in the index of 1 0. And how I am actually adding into the queue? If how it is appearing, if my this 0 is appearing, so I will index at 4. If it is 0 is a valid one, I will add 8 here. This is all I will add. So now what I want to actually check, I want to check whether can I reach from this 0, can I reach from this index 0. How could I check? If my current position, is not my exceeding what is present here, if it is not exceeding that, then exceeding the maximum jump, current index position is not exceeding the maximum jump limit of this, then I can say I can reach from here. So I can reach from here. So you can argue with me, like, if it is a minimum jump. See here, I am starting the my loop from minimum jump. So in future you can see, like, one case arise, like it is not reachable from, as it is not containing the minimum. So as a, what actually I mean to say, this thing, this 4 should not only should we shouldn't only check the maximum jump. The j index is, it should present this way. What is present in here? Let's say q0 plus minimum jump, or q0 of maximum jump plus max jump. Correct? I have to check these two cases. So if my this index lies between this range, then I'm fine. If it is lies between this range, then it's fine. If it is not lies, if it is more than this range, that means I cannot reach from this 0. I need any place that is near, like what could be my near place. I'll look into that later. And if my 0, assume this 0, if it is present before my index my reach, I reach the before index. Like if it is, let's say, we will understand like why it is when it is come. Right now I'm checking whether I can reach the current index from the index present in the front of my queue, in the front of the queue. What my front of the queue will store? It will store a index of which is containing 0. The queue always store only those indices that will containing 0, nothing else. Correct? So my current is like, can I reach from? So my target is, can I reach this zero from my this any index what is present in the top of the queue? Otherwise, we will see. Right now, we can see what this 0. What is the maximum is 6. What is the index is 0. 0 plus 6. So this 0 is nothing but it belongs like it is in the range of the first index. Is this 0, this fourth index, the 0 of the fourth index is belong in this range, so I can reach from this here. So I will simply add into the queue. I will simply add it. I will not do anything. Okay, I will simply add into the queue. So what actually I want to do, simply add. So I am doing what? Queue dot add index I. Can we simply do the index add into the index? We'll think it later. Think it later. Okay. So okay. Now let's see. Right now I can simply add. For this test case, it is fine. I can simply add right now. Okay. So what can I do right now? Another case. Now this is done. This loops will end here. This loops will end here. And again, now this is done. My I will point one. This is one. It will come one continue one continue. This is one. So now it is 8. This is 8. So I will not pop anything right now. This is 8. Okay. So right now I am currently at 8 index. So I'll check, can I get this index? Can I reach this index position? I want to actually say, can I reach this index position? So for this checking this purpose, I am checking this one. So what is present in the queue? This 0. So I'll check first this 0. Can I reach from this? Can I reach from this 0? Is it 0 is 0, maximum is 6? So maximum I can reach the C up to 6 index. But my current index is 8. So I cannot reach from this index. So if I cannot reach, like current index is 8 and this index cannot reach from this 0, whatever the 0 appear in future, that will also cannot be reached from this 0, correct? So can I assume? So I need to check. This is not, I cannot reach from here. So can I get any other index in the queue if there any other cases that is appeared in the queue from where I can reach in the 0? So I have to think this way. So is there any other queue, any other 0 is present before me from where I can reach? Okay. And I am inserting any 0 in the queue if and only if that 0 is reachable. I insert this fourth index here because this fourth index is reachable from where? This index. So if I have to check in the queue, is there anything present? Is there anything present in the queue? So from where can I say, like I can reach? Correct? I can say I can reach. Otherwise, there is no point of like if the queue becomes empty, then I cannot able to reach. I'm not able to reach. Clear right now up to this? So what I mean to say, this queue is nothing storing nothing but reachable zeros. What is the valid reachable zero? If the queue is not itself empty, queue becomes empty. That means even though I get zero, queue is empty. That means that zero is not reachable. That zero is not reachable. Correct? So I will simply return that zero is not reachable. So I will simply return false. Okay. So that condition I will come. I will give you an example. Then I can write in the code. But right now, see, so I can say like this queue is not empty, right? So I can pop this element and check whether can I get any other zero, any other index or zero is present that is also reachable. So what can I see here? Next is 4. So can I reach from 4? From 8 from 4? So 4 is what? 4 is nothing but index is 4 and maximum limit is 6. So 10. So for the index 4, I can take any 0 up to index up to index 10. Up to index 10. I am not checking the below index. Okay. Like I am not checking this minimum case. I'll check this later. You will understand later. But up to this, I can take any index. Correct. So yes, I can reach. So 8 can think. Okay, 8 right now it can think. Yes, I can reach from index 4. 8 can think I can reach from index 4. Correct. So so what actually I am doing? So here I am writing one loop. Here I am writing a loop. In the loop, what I am checking, if while while my queue is not empty, while my queue is not my empty, queue is not empty, is empty. If it is not empty, and what I am checking, and if it is not empty, then I am checking. But if I am checking, and if I am getting my current index I is greater than what is present in the queue of front plus my maximum jump maximum jump. That was I am checking. Like that time I have to pop the item. That time I have to pop the item. Correct. So that's what I'm doing here. When I was 8, I have to check, can I reach what are the item present in the queue? If the item if fast item is not if fast item is not reachable, like from I cannot reach from the fast item, I can pop, because I know, like, if I am not reachable, my future version, future zero series are not reachable. So I'll just simply pop that item. Correct. Then I have to check what is the present in the next item. Can I get that thing? That's why I'm checking. If the queue is not empty, and say assume and my current limit, my current index position, what is present in the front of the queue, and what is the reachable length is front plus max j, front plus max j, that is can we can reach. So if my current index is out of the reachable index of the my front item, I'll simply do what? I'll simply pop this item, q dot pop, q dot pop, right? Simply q dot pop, simply I'll do this thing, correct? Okay. And after that I will again add into the queue, like again I am adding, then I got the 4, then this is 0 is popped out. Next item is what? Queue is not empty again. The next item is queue dot front. Front is what? This one 4. Okay, this one is 4, correct? So this one is pop, so I can add this 8 item, so I can add 8 here, 8 here I can add. So now this is 1 again, now this is 10. Okay. Okay, so let's see what will happen in the 10 case. 10 case what will happen. So I will check again with the fast item, like what is present in the queue. So 10 will come here, and this is 10. It is here, it will come. Queue is not empty. I'll check with the fast element. So if my 10 is greater than my what is present in the queue, front of the queue, and is it exceeding the limit? It is outside the limit. So outside is 10, and what is the limit? I can say 4 plus 6 is 10. So 10 is not outside the limit. So I can simply add 10, do nothing, simply add 10. Okay, fine, 10 is done. Now it will come here, then it will come here, then I will come in 13. Let's see what will happen in the 13. So what will happen in the 13? So 13 I can come here, and what is I will check. So what I can check, 13 here, what I can do here, 13 in this 13. So from which index I can reach to 13? So I will say again 13, then I see queue is not empty. So I will check fast element. From fast element, can I reach 13? So as you know, like my 4 plus limit of that 4 is 10. So this 13 is clearly outside my range. So I'll pop this element. So I'll pop this item. Simply pop item. Next item is 8. 8 plus 6 is what? 14. So 14 is actually good thing. 14 is actually good thing. So I can append 13. So but here 13 is my last index. See, 13 is my last index. So why to add into the queue? Why to add into the queue? Instead, when I'm before adding, if I get the thing, I knew, if I knew, like if I get like I is nothing but if I going to add, but before adding, if I get my item and it is a last index, if it is I is nothing but n minus one item, so index is last index, then I can simply say why to add, directly return true, directly from here just return this, I got the true. Okay, so I can got the return true, it's fine. So this is right now, this is my algorithm. Now let's give you an example. Let's give you an example. Say I'll take only this example only. Let's change some digits. So first of all, make this thing. Okay, so what could you do? I just simply interchange this 0 and 8. 0 and let's select this 7 and 8 index and just interchange. Let's solve the problem again. Then we will see. Like here I am simply adding into it, right? So what I am checking. Again I will start with the 0th index. 0 will be inserted here. Then I start my indexing from min jump. Min jump is 4. 4 and 6 as it is. It was there. 4 and 6. Okay, so it will come here, it is 1, it will come here, it is 1, it is come at the 7th. Okay, 4 is also added. Okay, so min jump is 4, 4, and what was that I was checking? This 4 is checking that 4, wait, is the 4 is the within the range of the what is present in the front queue. If it is present, I will add it simply. I am doing that add, right? Now, can we do the such simple add? No, I was not checking that min jump case, right? I was not checking. What was the thing? That should be q0 or q front plus min jump, and this index I should be range between this, correct? So q dot front plus maximum, this case, it should case this. Earlier I was checking only this case, right? I was not checking this one, I was simply adding. So that's what I have to check. So what can I do? I can check before adding it. So here I can come here, and then I can come here. It is now I can come 7. Now 7, you can see 7 here. It is saying it is Q front. It is exceeding the limit of the first item present in the Q front. So I'll simply pop it out. Fine. So now it will come to the fourth index 4. Now it will 4. Now 4 is what? 4 is maximum is 6 equals to 10. So it is not exceeding. So earlier I was adding. But can I reach this from 4? Can I reach this from 4? No, correct. No, right. I cannot reach this from 4 because why? Because if see what is the min jump is 4. So 4 min jump is 4 plus 4 is 8. Current index is what? Current index is 7. So it is not inside my minimum jump. So that's why I can't add. So I can't add. So this thing, adding thing before adding thing, I have to check this thing. I have to consider this condition. If my current index I is less or equals to, if it is less or equals to, then only I can add, sorry, not less, it should be in the range, right? It should be I should be not less, greater equals to. It should be greater equals to. It should be greater or equals to current index I, that is q dot front plus minimum jump. It is in that range, then only I can add, otherwise I can't add. Okay, fine. So that is the case. So I will check it here. Why I can check this condition here? Why I can't check this condition here? Because it could not be the case of, if I check it here, so what will happen? Okay, let's take a good example, then you can understand. If you take an example, this is not a good example actually. What will happen, you can understand in a different example. So let's take an example 0 11 00. So let's write 0 11 00, then 111 000, then 1 000. Example. So okay, so before the going to the example, let's see what are the thing like 0 1 2 3 4 5 6 7 8 9 10 11 12 13 and 14. Okay, before going to the example, so if I want to include this thing in this condition, I have what I have to do, what I am checking, if it is outside of the range. So if it is outside of the range, I have to check the or condition. If it is outside of this range or outside of the this range, this is the condition I should check. Anyone should be true. What condition? So that time I have to write not only this, I have to use another bracket here, or I is less than q dot front min j plus min j. Whatever I am checking here, that opposite I have to check. That only I have to check here. Uh, let's see what will happen in that case. In that case, no need to write this if statement, correct? If statement. Okay, let's see what will happen. So if I check here, nothing but, so 0 will be by default here, 0 will be here. It will start from min jump. What is the min jump? Min jump is 3 and maximum is 5. Okay, okay, so 0 starting from min jump 3. So 3 I will check. So whenever I am checking 3, now it will check queue is not empty. So I will check whether like uh, fast, okay, fast this check, fast I have to check this one, then I can check next one, right? I can check this one. Okay, so first I'm checking whether it is inside my uh, front, like minimum item or from. What is my minimum item is right now? Right now it is 0. With 0 plus 3, it is 0. So it will say yes, it is true. So whenever it is true, it is OR statement, right? So if it is OR statement, that means we will not this check this condition. It will simply do what you can see. It will simply pop the item. It will simply pop the item. See here, it is true, this is true, and this becomes true, this becomes true. So it will simply pop the item. 0 will simply pop the item. So for now you can think like it is not a big deal, I can pop the item. Let's pop the item and insert the 3 here. So fine. Now I'm coming to the 4. When you see, when I'm coming to the 4, now you see what? Now you see what? This thing is actually, um, sorry, not here. Like if it is 3, and it should be the current of I, is it less than my Q of front? Q of front is what? 0 of 3, it is 3, but it's actually not less than, it is not less than actually, it is 3. Sorry, my bad, it is 3. So my current jump could be 3, current jump could be 3, and current maximum jump also 3. So this I is not less than actually, not less. It is actually same, not less than. If it's not less than, I will not pop anything. I will add into the queue. So I will add 3 here. What will be the next case? Next will be 4. Next will be 4. In the 4, what will happen? My fast is 3. Fast was 3. Correct? It was 3. So sorry, fast was 0. What is the range of the 0? 0 is nothing but um, 0 is nothing but 0 plus 3, that is 3. So what is current item is 4. So current item is 4. So 4 is not less than. So it will come this check. Is it greater than or my index max? 4 is it greater than? What is the maximum of this case? 0 plus 5. Maximum is 5. 3 to 5. So the current range is 4. So it is not minimum. It is not minimum. Not in the also not exceeding the case. So this 4 is entirely reachable from 0. So I'll add 4 into here. Correct? Fine then. So then I will keep checking. This is not checked. This is one I not need to check. For 8 I can check. From 8 I can check. Okay. From 8 I can check. So what is the case? Okay, I'll not remove from 8. So currently I'm at 8 index. So 8 I'm checking. It will check, is it less than my case? It is 8 is less than my from 0. It is not less than, it will come here. Is it maximum? It exceeding the maximum range of the fast index present in the queue. Yes, it is exceeding. I will pop that queue. Okay. Now it becomes 3. 3 plus 3. So it will be 3 and 3. So 3 plus 3 will be 6 and 3 plus 5 will be 8. Okay. So right now this thing, this I will check like is this 8? Is this 8 is actually inside my case? Yes, it is inside my case. So I will simply inside the range it is 6 and it is in the 8, so it is, I'll simply add into the here. Fine. Then 9. Now check the 9 case. Now okay, the 9 case. The 9 case it will do, it will say it is a 9, it is less than, like I'm checking here, I'm checking q front is less than minimum. No, it is not the case, it's a false, but Here it is exceeding the case. Here it is exceeding the case. So exceeding in the case, that means I am exceeding this case. I am exceeding this case. Correct. So like 3, it is exceeding my current, exceeding the range of the current position. So current position is 3, maximum range is 8, so I am exceeding. So 3 will be popped out. 3 will be popped out. Fine. Nothing big deal. Next item is 10. 10 is do what? See here. Yeah, what will be the current index? Current top is front is 4. So what is the value of that? 4. 4 plus 3 7. 4 plus 5 9. Okay. 4 plus 5 9. So now 10 is actually doing what? 10 is saying, can I reachable for 4? Reachable for this 4. 10 be like, no, you are not reachable. You are not reachable. Correct. So if you are not reachable, say here 7 is, it is fine, this is fine, but this is overruling the case. This is overruling the case. So in this it is overruling. This thing is overruling. So I will pop the 4 because see here current index is 10. Current index is 10 and maximum range of this 4. This is a valid case. So I am overruling the case. I am overruling this thing. Like I'm popping this 4. Now what is my present? Present is 8. So what will be the case? 8. 8 plus 3, it will be 11, right? 11. And 8 plus 5, it will be 13. So current range of 8 is that. Current range of 8 is that. See here, 10 will think like, okay, I am not reachable. I am not reachable from 8. I am not reachable on 8. See here, I am not reachable from 8. So I am discarding this 8. Discarding this 8. So should I do that? Okay, I forgot to write 9 here earlier. So should I do that? This 8, should I do that? Discarding that 8. The current index is not reachable. It's fine. But in my future, some of the index could be reachable from this 8. Could be reachable from this 8. Correct? So that is the thing I am saying. If it is not reachable from the top of the index, top of the queue, what is present in the front of the queue. So if it is not reachable that thing, so I shouldn't add the thing into the queue. Shouldn't add thing into the queue. I shouldn't discard from the queue because it is in the future. It is entirely possible. It is entirely possible. Something is reachable from it. So that's why we are not checking this case. We are not checking this case in this while case. We are doing only this check only. This check only we will do. Like if it is exceeding the top of my queue, see here. And what I am doing actually, I am actually adding 10 because it I'll discarding 8. The same reason I will discard 9, and I am not doing any check here, and I am adding 10 here. But should I add 10 actually? 10 is not at all reachable. 10 I anyhow cannot reach. From here I can jump here or here. Both are reachable. 3 I maximum jump 8. 3 plus 5 8. 4 4 I can maximum that 4 plus 5 9. This 10 is not at all reachable, but I am adding into the queue. If I don't write this condition here, I am adding into the queue. So adding into the queue means I am assuming 10 is reachable. In the queue, what I am adding actually? What is the index? Zeros are reachable. 10 is not at all reachable. Still I am adding into the queue. That's the reason. That's the reason I cannot check this thing here. I have to check whether that is my reachable or not. That from 4 or from 8, that is inside my range. Like I have to check this 10. Can I get this change from 8? Can is it inside the limit of that, or should I tell for 10 I'm checking is it maximum exceeding my case? Like for 4 it is what? For 4 it is exceeding. Yes. 10, from 10 I cannot reach. From 10 I cannot reach. Okay. But from 8 I may or may not reach. So 8 actually it is checking whether it is actually right side of that. Whether it is checking right side of that. Okay, right side of that, that's only not only check but also why I'm checking this q front of max, why I'm checking this limit. I'm checking this limit just because of I have to check this 4. If I am not, I'm exceeding its range, I'm exceeding its range is up to this, I'm exceeding its range, I have to discuss and find anything. Can I belong to in this range? What is the maximum range? It is for 8, maximum range is what? 8 plus 5 13. So I may is maximum range is 13. I may present in the maximum range. Okay. So I will not discard this 8 because I may present inside the maximum range, but I may not present of the minimum range. Okay, so that I will check later. For as I am not present, the current index is not present in the minimum range. Doesn't mean the future index cannot present in the minimum range. In future, earlier what are the zeros are there, it may present in that current index range, right? So that's why if I am just checking for myself, I am checking whether I am under his guidance, under his range or not. What is present in the top of the what present top of the queue. So I'm just checking whether I am the person of current index say for the current index saying I am present in that or not. So I am eligible or not, should I reachable or not, that will check later. But current now this is one step of verification that I am inside the one range. Now I have to check again right now if I am also belongs to the minimum range or not. If I am not minimum range, I am not at all reachable. I am not at all reachable. Okay, so that's why we can't check it from here. Hope you get it. So that's why I only simply check only whether I am the person that which is I am belongs to the maximum range of the front of the index position. What is present in the queue front of the queue? I am belong to the that range, maximum range. Now, if I have to be valid, then I have to be also eligible from the minimum range of the front of the queue. Okay, I also belong to the minimum range of the front of the queue. If I am doesn't belong, I belong from the in the maximum range, but I am not belong from the minimum range. Okay, so that means I am not part of the queue. That means my minimum range starts after me. That's what is happening here. 8 is starting 8 plus 3 11. It is starting from here. So there is a reason we check this condition at the end. Okay, so you are getting it. So that means I will, if I do the normal case, so 10 come check here, it will say I am not part of 8, but I belong to that 8. But when I come in here and checking, can I belong to like what is called this case? And I belong to the minimum range as well. So it is saying my range starting from 11, but you are 10. So you are not belong. So 10 say, okay, I am not part of it. I'll pass. And 11 come here. Now 12. 12 check, can I belong to the range of 13 from 8? Yes, it is maximum range. I belong to the maximum range 13. And it's a part of minimum range. Minimum range is what? Minimum range is 11. 12 is clearly qualifies. So I'll add 12 here. Next will be 13. 13 say am I eligible for maximum range? Yes, like maximum range is 13, you are not greater than that, so you are eligible. And it is saying am I also eligible from the minimum range? So minimum range should be greater or equals to I am 11 is the minimum range, I am 13, so it is also fine. 13 is also reachable, that's also fine. Now comes in the 14. 14 will say am I eligible from 8? It say no, my maximum range is 13, so you are not eligible. So I am 8 say I am going outside. Now 9 will take care. Whatever is my it may possible what is present, what is the reachable zeros are present after me. You may reach from there. You may reach from there. So 14 said okay, 11, 8 is popped out. 14 will 9 check from 9. But 9 what is the 9 plus 5 is 14. 9 plus 5 is 14. So it is reachable from 9 is reachable. Maximum minimum range what will be 9 plus 3 will be 12. 14 is greater than 12. So for 14 say okay I am eligible. So it is going to add into the queue. But before that it is saying am I the last element? Yes, you are the last element. Directly return the element. No need to check or add anything. So it will directly return the element. This is what okay. Now last case, if this is not reachable, nothing is reachable. So let me give you that example. So let assume take 0 0 0 0, okay, 1 1 1 1 1 1, and this 0. That is the case. 0 1 2 3 4 5 6 7 8 9 10, and minimum, let's say my minimum is 1 and maximum is, let's say, 3 or 2. Okay, so what will happen here? Let's start our algorithm. So 0 will be by default added. My current minimum jump start from minimum, then this is minimum jump. I will check whether this 1 is belongs to my maximum of this is 0. Maximum of 0 is 0 plus 2, 2. Maximum range is 2. So 0 can be reachable from, like 1 can be reachable from 2. Now I have to check if I can belongs to minimum range as well. Minimum range is what? 1. 0 plus 1 is 1. So it is also, it is equals to, it's starting from minimum range. So I will add 1 here. Okay. Then I'll come at the second place. Second place also find it out, like I am also belongs to the maximum range of 0. 0 plus 2 is 0 because maximum range is 2. So this is find the maximum. So can I belongs to the minimum range starting from 1? So starting from 1 is, so I'm greater than 1. So 2 is also added. Okay. So right now see here. Right now what will come, like it will come at this third index. Third index say, like, can I belongs to 0? Can I belongs to 0? So 0 will say, no bro, you cannot belong, you are not belong to my maximum range. My maximum range is 2, so you are not belong to my maximum range. Okay. So 0 say, I will pop it out. You can check my next element. So now it is checking, is it 1? 1 is, can I belong from 1? Yes, you can belong range of 1. It will be 2. It will be 2. 2 plus 1 plus 2 is 3, so it is maximum range is 5. Minimum range is what? 1 plus 1 is 2. So it is also after the minimum range. So 3 is also eligible. So 3 will add. So after that, I becomes here. It is not 1, not 1, not 1, not 1, not 1, not sorry, not 0. All are the 1. So I'll continue. Now I will come this 10, the very precious 10. What happened here? See, 0 or 10 will say, can I reachable with the first item? 1. It will say, no, you are not reachable. My maximum is 1 plus 2, 3. Or not, you are exceeding that. So pop that item. 1 is popped out. Next 10 will compare, like, am I reachable from this one? This two say no, maximum item is 4. You are out of my case. So pop this item. Also pop. Now again it is checking with the 3. Am I reachable from you? Because 3 is inside the queue and 3 is also reachable. Inside the any index from the present in the queue, that means it is reachable. Less than 10 saying like no, it is also not reachable. So 3 will pop. Now think nothing present in the queue. This loop is ends because queue is empty. Because queue is empty. So it will end if queue is empty. So can I add 0 inside here? No, I cannot add 0. Why I can't add 0? Because my queue is empty. Now queue is empty. Okay, so assume there are many places, many things are there as well on 1000. No matter what items are present after that, I am not present, not kind of reachable. This index is not reachable, and my queue is also empty. If queue is empty, in future nothing is reachable. Okay, this queue is empty. This 10 is not reachable from any places. So that means in future, like what is and 10 is not reachable from anything. This first thing will think like what is it? It is reachable. Like it is a what is the reach, like fast loop actually validates what? It validates what is the thing present in the current index. What is the my current index is it is in the range of any reachable index. This is the fast loop checking. This is it reachable from the from any is it reachable of the any previous index, not properly reachable, whether it should belongs to the like my maximum range of any reachable index. That is the checking. So if previous reachable index, if the current index is not and inside the range of the maximum range of the previously reachable indices, that means whatever present after me, after current index, that is also not reachable. If this current index, this doesn't belong to the maximum range of any reachable index. That means what are the indices present after this current index that are not also reachable from the previous reachable index. Hope you are getting it. Because this one, it doesn't belong to the maximum range of any of the previous reachable index. So how is it possible like this will belong to that maximum of the any reachable index? Hope you are getting it. So that's why here I have to do another check, another if condition I have to put. If my queue is empty, if my queue is empty, that means simply return false, like it is not reachable. So simply return false. Got it? So these are the simple case. So at the end of the loop, you can return false. Like if it is returned true, then it should be returned true by here, right? So at the end it will return false. If I loop somehow it ends and I didn't reach the case, it will be false. Okay, return false, and this is the stop the thing. So this is the whole algorithm. This is the whole algorithm. Let's see the time complexity. Clearly, this is big of n, because minimum j can be 1 as well, big of n. Now you can say like there is a kind of this thing is happening, right? This stack is happening, stack thing is happening. But the thing is, this queue thing is happening. But this is, see here, only one index. If it is inserting, it is popping out one time, right? Any index is present, it is not checked twice or thrice. Like it will just come here, like whatever the index, I'll just check. If it is there, I'll simply break the loop. I will iterate or break. Even though, see here, for 3, I was checking this one, this one, this one, or not. I am just simply checking this one and check. For 10, I am popping this one, I am popping this one, I am popping this one. For 10 here, it is taking more cost. In the cost, in the sense like I am popping out 3 elements. That is the cost, popping out and inserting. It is simply taking many cost, but inserting is outside of the loop. Popping is inside the loop. So, but for this one, am I popping anything? No. For 2, am I popping anything? No. For 3, so let's assume it is a 3, not 2, it's a 3. So in that case, 0 will insert, 1 is reachable from 0. I simply check this one, it is true. So it becomes actually false. So this pop will not take place. I will insert 1. 2 I will insert because it is reachable from 0. 3 I will insert. But 3 here, for these 3 cases, these 4 cases, I just simply pop, push, and add into the queue. While loop didn't even run. For this case, it will pop 4 elements. But the thing is, cost is adjusted. Here it was for when my index on this, it was cost of this while loop is 0. Here cost of a while loop is 0. Where cost of this while loop is 0. Here cost of while loop is 0 because it's not even executed. Here it is cost of while loop is 4. So earlier cost was 0, fourth time cost was 0, one time cost was 4. So it is distributed. It is distributed. So one time it may take maximum of time, but that many times other cases you will not take anything. So that is, so if, please remember this thing, if if in the queue I am putting one item in the queue only once and popping only once, later I didn't push it again, the same item. If I didn't push it again, that means it is taking big of one time. I'm just putting it and just taking it outside. It is take big of one time. So that's why overall it will take big of one time. Overall, I'm taking overall. Overall case it will big of one time. So time complexity is nothing but big of n, but space complexity is I'm taking one extra queue. So big of n as well. Big of n as well. So hope you are getting it. This is the approach. Another was BFS. I'll upload the code of the BFS and I'm shown as well here. If you know the Python, you can see this is the BFS code. I'm not explaining. The BFS is a basic concept. So I'll upload that code. But this is the proper approach to like proper way we can solve the approach. There are many other way as well. This is one of the way. Okay. Okay then. Hope you understand the problem. So as always, if you find any mistake in this video, please let me know so that I can rectify. And if you find any more useful informative video on this topic, please also comment it down so that I can also like. Thank you. Bye bye.